Welcome to our quick summary series. This is a quick fire summary video. For a longer, more detailed explanation, head over to reviseitright.com. Make sure you subscribe to our channel and turn on that notification bell so you don't miss our 10 minutes a day daily revision, uploaded every day. And if you do enjoy this video, please give it a like. Nuclear equations show radioactive decay. When working through these equations, you must remember that the mass must be the same on each side. We will first work through alpha equations. This is the symbol for alpha particles. Remember, it is a helium nuclei that contains 2 protons and 2 neutrons. This is the proton number and therefore shows it has 2 protons. And this is the mass number. So it shows it has 2 neutrons. If an element goes through alpha decay, it will lose 2 protons and 2 neutrons. This means it will lose a mass of 4 and a proton number of 2. Let's go through a worked example. Write the nuclear equation for oxygen going through alpha decay. Step 1. We know that alpha decay is 2 protons and 2 electrons, so we can write this in. Step 2. We need to find the new element this has now become. Oxygen has lost a mass of 4, so we can do 16 minus 4 to find the new mass. This equals 12. The new mass is 12. Step 3, find the new proton number. It has lost 2 protons. We can do 8, which we've taken from here, minus the 2 from the alpha to make 6. Look on the periodic table for the element that has 6 protons, as that was here. This is carbon, so the new element will be carbon. We'll do one more. Thorium-234 going through alpha decay. So again, in step 1, we know that alpha decay is 2 protons and 2 neutrons, so we can write this above. Step 2, we need to find the new element this has now become. Thorium has lost 4 mass, so we can do the 234 minus the 4 to find the new mass, so it's 230. So we can write that in. Step 4, find the new proton number. It has lost 2 electrons, so we take the 90, take it away from the 2 to get 88. So we write that in. And step 4, we need to look on the periodic table for the element that has 88 protons, so the new element that it has become. This will be radon. Again, double check the answer. Does it have the same total of mass and proton number on each side? We will now look at beta radiation. Here is the symbol for beta particles. Remember, it is just an electron. So they have a mass of 0 and a charge of -1. The proton number is -1 and the mass number is 0. When an element goes through beta decay, a neutron in the nucleus turns into a proton. This causes the charge to go up by 1. Let's go through a worked example to explain that. Thorium going through beta decay. So step 1, this time we're doing beta and we know that it is an electron, so we can write in this into the equation. Because splitting an electron has no mass, the element has not lost any mass. So we'll do 234 minus 0 and it will still be 234. So we can write that in. Then we've got to find the new proton number. Remember, in beta decay, a neutron turns into a proton. So it gains a +1 charge. So we do 90 plus 1 and it will equal 91. Then we need to look on the periodic table for the element, the new element that has 91 protons. It's protactinium. Then we need to double check the answer. Does it have the same total mass on each side and the same proton number on each side? Yes, it does. Therefore, we must be correct. We will now look at gamma radiation. Gamma radiation is an electromagnetic wave and has no mass or no charge. Here is the symbol for gamma radiation. Here, remember, is the proton number. So 0 protons because it's a wave. And here is the mass number. 0 mass because it's a wave. This makes these nuclear equations very easy as there is no change. Let's do a worked example anyway. Thorium going through gamma decay. Again, we'll draw out thorium. We know that gamma decay is a wave, so we can write this here. Because spitting a gamma ray has no mass, the element has not lost any mass. So 234 minus 0 would still be 234. Again, to find a proton number, it's not lost any protons, so it'd be 90 minus 0, which is still 90. It is the same element because it's not changed in its proton number. So we write that. Double check the answer, make sure it's not changed, and there it is. Easy. You have now learnt about nuclear equations. You will find a summary of this information below. Make sure you test yourself using the quiz on reviseitright.com. Remember to subscribe to our channel and turn on that notification bell so you don't miss our 10 minutes a day daily revision uploaded every day. And if you did enjoy this video, please give it a like. We are super excited here on reviseitright.com about the launch of our brand new website. I just wanted to quickly take you through some of the amazing features on our site. Here you can make a profile just like you can on other social media websites, but this one is all about revision, the very first of its kind. You can write in questions here, for example, so can someone help me with the function of bile? You can post it and one of our tutors or another member of the community will get back to you. We're really excited about the revision community we can make here. If you go to the Learn part, here you can have access to text, videos, and quizzes from all the topics you will need in GCSE Science. You'll have access to all the summary videos that we have on YouTube, but also much longer videos that aren't available on YouTube that go into real detail on each topic. We will also have daily and weekly revision challenges for each biology, chemistry, and physics. New challenges each day. And this will link in with the leaderboard so you can compare how you're doing to how everyone else is doing. And really excitingly, you can also book extremely cheap group and private revision classes with one of our tutors. We'll be updating the website all the time, so head on over to reviseitright.com and sign up for a free account today.